Today I'm presenting on road salt infiltration in the Provincial Groundwater Monitoring Network within the Toronto and Region Conservation Authority. This presentation is heavily influenced by a presentation I saw at GeoNiagara in the fall of 2021 by Dr. Richard Jackson focused on municipal supply wells. I was curious about whether TRCA's Provincial Groundwater Monitoring Network dataset would show similar patterns. A brief outline for my talk today. I will address health considerations related to sodium and chloride, what molecular ratios of sodium to chloride tell us about saturation levels generally, about the groundwater monitoring network within the TRCA, chloride and sodium levels observed at PGM wells, what molecular ratios of sodium to chloride tell us about saturation levels within the Greater Toronto Area, and a few concluding thoughts and recommendations. Health Canada's drinking water guideline is 250 milligrams per litre for chloride and is 200 milligrams per litre for sodium. Both criteria were published in 1979, over 40 years ago, with chloride being reaffirmed in 2005. With respect to chloride, Health Canada's chloride value is primarily based on the potential for corrosion in municipal distribution systems, as health effects are generally not a concern at levels found in drinking water. With respect to sodium, Health Canada's sodium value is primarily based on taste, as sodium can generally be tasted in water around 200 milligrams per litre. Health Canada notes that for people on a strict sodium-reduced diet applying to all sources, levels in drinking water should be below 20 milligrams per litre, and that where a sodium-based water softener is used, a separate unsoftened water supply for cooking and drinking purposes is recommended. From a practical perspective, assuming adults drink roughly 2 liters of water per day at 200 milligrams per liter, drinking water would contribute just over 25% of the recommended intake of 1,500 milligrams of sodium for someone with hypertension, and therefore the recommendation for less than 20 milligrams per liter. While sodium poses a greater threat to human health than chloride, working for a conservation authority, I wanted to touch base on ecological considerations associated with chloride and groundwater contribution to base flow. The long-term ecological guideline of 120 milligrams per liter in surface water, roughly half the 250 milligrams per liter guideline for drinking water, should be kept in the back of our minds when we look at chloride levels observed at PGM wells later in the presentation. We tend to focus on salt application and the extent of paved surfaces when discussing the resulting chloride concentrations at nearby wells. And indeed, salt application rates have increased and paved areas have widened. But also we need to consider the state of road salt contamination along the flow path leading to the well. To this end, we can use the molecular ratio of sodium to chloride to provide an indication. We see the dissolution of salt into saline snowmelt between 0 Celsius to 10 Celsius, and where infiltration into the subsurface occurs, we see a cation exchange of calcium for sodium. This cation exchange retards and stores the sodium pulse in the subsurface. Initially, a ratio of 0.6 might be expected, indicating sodium retardation. But eventually, with annual recharge of saline snowmelt, a ratio of 1 should be expected, indicating a fully saturated flow system. TRCA's monitoring network includes wells within the Provincial Groundwater Monitoring Network, monitoring wells required by permits to take water, monitoring wells required for larger ecosystem monitoring projects, as well as a handful of other wells. There are a total of 79 Sentry wells for TRCA. For the purposes of this talk, only 21 wells associated with the Provincial Groundwater Monitoring Network were looked at. Initiated in April 2000, the PGM was established to report on ambient or baseline conditions and to provide an early warning system for changes in groundwater quality and levels. Wells associated with the Provincial Groundwater Monitoring Network are distributed over 5 of TRCA's 9 subwatersheds. From west to east, the subwatersheds are the Etobicoke, the Humber, the Don, the Rouge, and the Duffins. In all subwatersheds, we can see an underrepresentation in the southern portions of TRCA. To look at chloride data, sampling events associated with each subbasin have been color-coded, blues and greens in the west and yellows and oranges in the east for the first slide. The color coding is dropped in subsequent slides where only one subbasin is discussed. The highest chloride levels are largely observed at the western and eastern suburban edges of TRCA in the Humber and the Duffin subwatershed. In the Etobicoke subwatershed, both wells are below the drinking water guideline and are located near Heart Lake Conservation Area. In the Humber subwatershed, 329 and 325 exceed Health Canada's drinking water guideline. 329 is located near Albion Hills Conservation Area and 325 is located near High Park. In the Dawn subwatershed, data is scarce, with only one well and two sampling events. 17 is below the drinking water guideline and is located near Earls Bales Park. In the Rouge subwatershed, 382 exceeds the drinking water guideline and is located near Mills Park. In the Duffin subwatershed, 382 exceeds drinking water guideline and is located within Seton. Similarly, to look at sodium data, the sampling events associated with each subbasin have been color-coded, blues and greens in the west and yellows and oranges in the east for the first slide. The color coding is dropped in subsequent slides where only one subbasin is discussed. Again, the highest sodium levels are largely observed at the western and eastern suburban edges of TRCA in the Humber and the Duffins. In the Etobicoke subwatershed, both wells fall right around the drinking water guideline for people with hypertension and are located near Heart Lake Conservation Area. In the Humber subwatershed, 329 generally exceeds Health Canada's drinking water guideline and 325 falls just below Health Canada's drinking water guideline. 329 is located near Albion Hills Conservation Area and 325 is located near High Park. In the Dawn subwatershed, 17 exceeds the drinking water guideline and is located near Earls Bales Park. In the Rouge subwatershed, 382 exceeds the drinking water guideline for people with hypertension and is located near Milne Park. In the Duffin subwatershed, 382 exceeds the drinking water guideline for people with hypertension and is located within Seton. Finally, to look at molecular ratios of sodium to chloride, the aforementioned color coding of blues and greens in the west and yellows and oranges in the east has been retained for the first slide. The color coding is dropped on subsequent slides where only one subbasin is discussed. We can observe that many sampling events at wells within the Provincial Groundwater Monitoring Network recorded fully saturated conditions. However, a significant number of sampling events took place before end-state conditions had been reached. In the Etobicoke subwatershed, only one sampling event in 2012 at 366 plotted above 1. All other sampling events plotted below 1. Both wells are located near Heart Lake Conservation Area. In the Humber subwatershed, most sampling events at most wells plotted above 1. However, 3 wells, 60, 325, and 497 plotted below 1. 325 is located in High Park, 497 is located in Kleinburg, 60 is located near King City. In the Dawn subwatershed, both sampling events plotted above 1. 17 is located near Earls Bales Park. In the Rouge subwatershed, all sampling events at 2 of the 3 wells plotted below 1. However, about half the sampling events at the 3rd well plotted above 1. 6 is located near Bruce Mills Conservation Area. 59 is located in Richmond Hill. 382 is located near Milne Park. In the Duffin subwatershed, all sampling events at 5 of the 6 wells plotted above 1. However, all sampling events at the 6th well, 517 Shallow, plotted below 1. 517 Shallow is located in Seton. I tried tabulating the data to gain additional insights. Here are a few of my takeaways. Groundwater quality was usually within the recommended limits for chloride at 250 milligrams per liter, and groundwater quality was usually within the recommended limits for sodium at 200 milligrams per liter. However, groundwater quality frequently exceeded the 20 milligrams per liter recommended for people on low sodium diets, and a significant number of sampling events at wells from the 4 of the 5 sub-watersheds with data available took place when fully saturated conditions had not been reached. Therefore, higher sodium concentrations may be occurring or will occur in the future than has been captured by past sampling events. The Etobicoke watershed and the Mimico watershed, based on groundwater quality data from the Westine monitoring wells not presented here, have particularly high chloride levels and low molecular ratios. Bedrock geology and overburden thickness could also be contributing some chloride in these watersheds. Consideration should be given into looking at chlorine isotope fractions within these subwatersheds to provide further insight into whether chloride is a result of natural or anthropogenic functions. It would be interesting to undertake this exercise again, perhaps including additional wells and presenting the data by well depth. Just before I close off my presentation, I wanted to provide a couple of references that I utilized in the preparation of this presentation. I'd now like to open the floor to questions. Thank you.